All right, hope everybody's doing well. Welcome to your first video for your summer assignment. Excited to have you guys in class, and hopefully you guys find this summer assignment to be beneficial for you as we kind of introduce you to some things that you'll be seeing next year in calculus. All right, let's go ahead and jump in right here. Let's start talking about limits. Okay, so the notation we're going to use whenever we talk about limits is this right here, and what that symbol basically says is that the limit as x approaches a of f of x is equal to L. And what limits help us do is they help us to kind of figure out what's going on with a function as x approaches a, which is some number, and it can help us kind of figure out what's going on with a function even if a function is not maybe defined at x equals to a. Okay, so kind of an example of what I mean, if you consider the function f of x is equal to x squared minus 5x plus 6 over x minus 3, the question is, what is going on at x equals to 3? Well, if you were just going to try to plug into this function and figure out what the y value is at x equals to 3, something not good is going to happen. Okay, you're going to end up dividing by 0, which means that f of 3 does not exist, and so this function is not defined at x equals to 3. So in order to figure out kind of what's going on with this function at x equals to 3, we can consider the limit as x approaches 3 from both sides of 3. So that's kind of what I've done with this table of values that you see. As you can see, as x approaches 3 from the left side, or from kind of the negative side of 3, then you can tell that f of x is approaching the y value 1. Okay, so notice that these numbers 0.5, 0.9, 0.99, 0.999, those numbers are getting closer to 1 as x is getting closer to 3. Okay, similarly from the other side of 3, as x approaches 3 from the right side, you can also see that the f of x values are getting closer and closer to 1. So what we would say in that case is that even though f of 3 is not defined, we can say that the limit as x approaches 3 of f of x is equal to 1. Okay, so that can kind of help us figure out what's going on with the function even though the function is not defined at x equals to 3. And that leads us to a very important point, and you're going to hear me say this a couple of times during the first weeks of class. And the point is this, is that the existence or non-existence of a limit has nothing to do with whether a function is defined at a particular x value. So what that means is the function value and the limit don't necessarily have to be the same. They don't necessarily both have to exist. And basically they just don't depend on one another at all. So these two pictures here kind of illustrate hopefully what I'm talking about. Okay, if you notice here at x equals to 0, so right here would be 0, this function has a hole at x equals to 0. So kind of similar to our function above, our rational function that we created the table of values for, this function has a hole, but because the function is approaching the y value 2 from both sides of 0, we can say in this case that the limit as x approaches 0 of this function f of x is equal to 2. Okay, so even though the function is not defined, and it says right here f is undefined at x equals to 0, we can still say that the limit is 2 as x approaches 0. Okay, and then in the other picture, notice here that there's also a hole right here at x equals to 1, but that down here the hole is filled in. Okay, so the question is, which one of those is the limit? Is the limit 3, because remember limit is all about y values, or is the limit 1, which is where this point is filled in? Well, the answer is that the limit is equal to 3. So we're going to say the limit as x approaches 1 of f of x is equal to 3, and that's even though f of 1 is equal to 1, which is represented by the ordered pair right here. Okay, so the limit really depends on where the picture is going, where the graph is going, if you will, and not necessarily on what the function value is or if the function value is even existent or defined. Okay, so hopefully that makes sense to you. You're going to have a couple of multiple choice questions to kind of practice this concept, and if you need help on those, then please feel free to contact me, and I'll be more than happy to explain it to you.